Hello everyone and welcome back to the Intro Algebra video lectures. Today we are going to be picking up where we left off in solving linear equations. Now in this video we're going to be looking at linear equations that take more than 2 steps to solve them. So there are going to be plenty of equations where there is more than one term that contains a variable. So when there's more than one term that contains the same variable, you need to combine those like terms first before you do any other solving. Because as you've noticed in the last couple of videos, you can start undoing the operations only when there's only one term that has the variable. If there's more than one term with a variable on it, you need to combine like terms first. And there are going to be two different ways that this is going to appear. There's going to be equations where the like variable terms are going to be on the same side of the equal sign, and then there's going to be equations where the like variable terms are on opposite side of the equal signs. So we're going to start with the two variable terms on the same side of the equal sign. So when your like variable terms are on the same side of the equal sign, you just combine like terms as you normally would, but you need to do that first. Then, once you have just one single term with a variable on it, then you can proceed to solve as you normally would by undoing each operation performed on that one variable term. So this first one is an example where we have two terms that have the same variable, and they are on the same side of the equal sign. They are both on the left side of the equal sign. So because these two are on the same side of the equal sign, solving this is actually really easy to do, because you're just going to combine these two like terms like you normally would. 2x minus 5x is negative 3x. Leave the equal sign where it is, and then 12. Now keep in mind, we're also going to see plenty of equations where you don't always have to do both adding and subtracting and multiplying / dividing. In this case, the only thing that you have to do to finish getting x by itself is divide both sides by negative 3. There's no adding or subtracting to even do here, so you don't need to do it. You're going to find that not all steps are going to be necessary for every single problem. So I'm just going to divide both sides by negative 3, giving me x equals negative 4 as a final answer. I also apologize for the lawnmower. They started exactly when I started recording, and there's nothing we can do about it. Anyway, so I want you guys to try this next one. Now remember, before you start undoing any opposite operations, you need to make sure that you have only one single variable term first. So this 7x and this minus 3x do need to be combined first before you do anything. So go ahead and pause the video and attempt this next one, and then resume the video when you are done working. All right, so the first thing that we're going to do is we need to combine these two variable terms into one single term that contains a variable. So 7x minus 3x is going to give us 4x. I'm going to leave the minus 6 alone, leave the equal sign where it is, and leave the 6 alone. Now that we have combined those two, and now that we only have one term with a variable, now we're going to start getting that variable by itself. So this is where we start doing the opposite operation. So I'm going to get rid of this minus 6 by adding 6 to both sides. That gives us 4x is equal to 12. Then I'm going to finish getting x by itself by dividing both sides by 4, and I get x equals 3 as our final answer. So that's how to solve equations where your like variable terms appear on the same side of the equal sign. When they're on the same side of the equal sign, all you have to do is combine like terms like you normally would first, and then begin to get the variable by itself. Now, linear equations where you have the same variable on both sides of the equal sign, this is going to be a little bit more complicated. You might remember that in order to move a term from one side of the equal sign to the other, you need to do the opposite operation, and then whatever you do to one side of an equation, you must do the exact same thing to the other. So if you want to move a variable term from one side of the equal sign to the other, it's going to be the same basic idea. You're going to move all of the terms onto one side of the equal sign and then combine them. Now, to move a term from one side of the equal sign to the other, you're going to do the opposite operation. So if the term that you are trying to move is positive, What you are going to do to move it to the other side is you're going to subtract it from both sides of the equation. That will cause it to cancel out on one side, and then on the other, it'll move to the other side, and then you'll be able to combine like terms. If the term that you are trying to move is negative, what you're going to do is you are going to add it to both sides of the equation. It will cancel out on one side, and then it will move over to the other. Now, generally, it doesn't matter what side of the equation you move the variables to. A lot of people, just by force of habit, will move it to the left side. A lot of people don't like working with negatives, so if you want to avoid negatives, you pick the side that will avoid a negative. But here's the thing. Commit to a side and stick to it. If you are deciding that I'm going to move all of the terms over here onto this right side of the equation, make the commitment and don't try to change your mind halfway through or move things back. Just make a decision, stick with it, and don't try to change your mind halfway through. So you're going to do the opposite operation to move all of the terms onto one side of the equal sign. Then, once you have just one single term with a variable on it, then you can start solving like normal. So this first one is an example where we have a term that contains our variable z on both sides of the equal sign. Now, technically, it doesn't matter what side you move all of the variables to, but all of the variables need to be moved to one side. This 13z is currently positive because there's nothing to its left. And this z over here is technically negative. So we have a negative z on the right and a positive 13z on the left. So here's one option. You could either move all of the z's over to the right side of the equal sign by subtracting 13z from both sides. Or you could move all of the z's to the left side of the equal sign by adding one z to both sides. And it really doesn't matter. I'm not a huge fan of subtracting with negatives, so what I'm going to do is I am going to add this positive 1z to both sides. But if you had chosen to subtract the 13z, I will tell you that it doesn't matter. Your work will look slightly different, but you will get the same answer in the end as long as you do everything correctly. So I'm going to add 1z to both sides of the equal sign. Now over here on the right, negative 1z plus 1z is 0. So those are going to cancel out. And the only thing left over on the right side of the equal sign is this 12. Then on the left, I have two terms that both contain a z. And I'm going to, now that they're on the same side of the equal sign, I'm going to combine them just by adding their coefficients. So 13 plus 1 is 14z. And then I'm going to leave that plus 5 alone. Now that all of the variables have been moved to the left side of the equal sign, and now that there is only one term with a variable, now I'm going to start getting that variable by itself. So the first thing I'm going to do is I am going to subtract 5 from both sides. That gives us 14z, leave the equal sign where it is, and then 12 minus 5 is going to give us 7. There we go. Then I'm going to finish getting z by itself by undoing this multiplication and dividing both sides by 14. 14 over 14 is 1 and cancels out, leaving you with z equals 7 over 14. Yes, it is a fraction, but please reduce all fractions. Both the top and the bottom are both divisible by 7, so please reduce 7 over 14 to 1/2. So z equals 1/2. I'll just write it over here. Z equals 1/2 is then going to be your final answer. So I want you guys to try this next one on your own. Use the example on the left as a guide. I want you guys to first move all of the variable terms onto one side of the equal sign and then start getting the variable by itself. So go ahead and pause the video and then resume when you're ready to check your answer. Okay, so looking at this next one, we have a positive 3x over here on the left side of the equal sign, and we have a negative 1x over here on the right side of the equal sign. Now I will say It doesn't matter what side you move them to as long as you pick a side and stick with it. Now, if you did this problem slightly different than I'm going to, don't erase it and think you did it wrong. Just kind of sit tight and see if you get the same answer. Your work will look different if you chose a different side than I do, but if you get the same answer in the end, that means you did it correctly. You just did it in a slightly different way, and that's okay. That will still earn you full credit. So we can do one of two things. We can either move all of the x's over to the right side of the equal sign by subtracting 3x from both sides. Or we can move all of the x's to the left side of the equal sign by adding 1x to both sides of the equation. I like adding better, so I'm going to add 1x to both sides of the equation. So then on the right, -1 plus 1 is 0, leaving you with, don't forget that 15 is negative, so there is a -15 left over here on the right. And then on the left, now that these two terms are on the same side, now we can just combine them by adding the coefficients. So 3 plus 1 is 4x, and then I'm going to leave the -12 alone. Now I'm going to start getting my variable by itself. So I'm going to start by getting rid of this -12 and adding 12 to both sides. So those cancel out, leaving you with 4x equals -15 plus 12 is -3. Then I'm going to finish getting x by itself by dividing both sides by 4. And yes, you can leave this as -3/4. That is fully reduced. And remember, you can get a fraction as a final answer. And you will get these a lot. So x equals -3/4 is your final answer. So we're going to do that same thing for these next two. So for this next one, we have 7 minus x is equal to 5 plus 3x. Keep in mind that a number always takes the sign to its left. So this x on the left here is technically negative. This is a -1x. And this x over here on the right is positive. This is a positive 3x. So you can do one of two things. You can either move all of the terms onto the right side of the equation by adding 1x to both sides. Or you could move all of the terms to the left side of the equal sign by subtracting 3x from both sides. And it technically doesn't matter which one you do, because even if you choose a different side than I do, the work will look different, but if you do everything correctly, you'll get the same answer in the end. So what I'm going to do, just to show you that, is I am going to subtract 3x from both sides to move all of the x terms to the left side of the equal sign. On the right, 3x minus 3x is 0 and cancels out, leaving you with 5. Now this 7 over here, this 7 did not have a variable, so I am going to leave it alone. And then over here, -1 minus 3, or -1 plus -3, gives us -4x. So now all of the variables have been moved to the left side of the equal sign, and there is only one term with a variable on it. Now this variable x is being multiplied by -4, so dividing by -4 is going to be the last thing we do. So that means the first step to start getting x by itself is to get rid of this 7. Now since there's nothing to the left of this 7, it is technically positive. So to get rid of this positive 7, I am going to subtract 7 from both sides. 7 minus 7 is 0, leaving you with -4x over here on the left. Leave the equal sign where it is, and then 5 minus 7 is -2. Then I'm going to finish getting x by itself by dividing both sides by -4. So that gives us x by itself now. And then on the right, a negative divided by a negative is positive, and then 2 over 4 reduces to 1/2. So x equals positive 1/2 is your final answer here. Now there are going to be plenty of equations where you have variables on both sides and some subtraction is inevitable. So on the left side of this next equation, we have a positive 5a, and then on the right, we have a positive 2a. So subtraction is inevitable. You can either move all of the variable terms to the right side of the equal sign by subtracting 5a from both sides, or you can move all of the terms to the left side of the equal sign by subtracting 2a from both sides. It doesn't really matter. Pick a side and stick with it. I'm going to subtract the smaller one just because I want to avoid a negative, but that's not necessary. So I am going to move all of the a terms to the left side of the equal sign by subtracting 2a from both sides. 2a minus 2a is 0, and that cancels out, leaving you with the 6 on the right-hand side. And then on the left, now that the a's are on the same side, I'm just going to subtract them as I see them. 5a minus 2a is 3a. And then I'm going to leave the minus 4. Then I'm going to start to get a by itself by adding 4 to both sides first. So negative 4 plus 4 is 0, leaving us with 3a, equals 6 plus 4 is 10. Then I'm going to finish getting a by itself by dividing both sides by 3. 3 over 3 is going to cancel out, leaving you with a, equals 10 over 3. So 10 over 3, you can leave it as a fraction, is your final answer. So I want you guys to try these two out for yourself. You are going to have to first move all of the variable terms onto one side of the equal sign. So I want you guys to pause the video, try these next two, and then resume when you are done working. All right, so for this next one, there is a 1x on the left side of the equal sign, and there is a 4x on the right. So you can do one of two things. You can either subtract 1x from both sides, or you can subtract 4x from both sides. And just to show you that it doesn't matter, I am going to subtract 1x from both sides to move them all to the right side of the equal sign. If you had subtracted 4x instead, your work will look different, but you should get the same answer in the end if you did all of your other steps correctly. So on the left, 1x minus 1x is 0, canceling out, leaving you with a 4, equals 4x minus 1x is 3x minus 1. Then I'm going to start getting x by itself by first adding 1 to both sides. So 4 plus 1 is 5, equals 3x. Then I'm going to finish getting x by itself by dividing both sides by 3. So x is now by itself and equals 5/3. So x equals 5/3 is then your final answer. So then for this next one, there is a 2x on the left side of the equal sign and a positive 1x on the right. So we can do one of two things. You can either move all of the x terms to the right side of the equal sign by subtracting 2x from both sides, or you can move all of the variables to the left side of the equal sign by subtracting 1x from both sides. I am going to subtract a 1x from both sides and move them all over to the left. So 1x minus 1x cancels out, leaving you with a 4 left over here on the right. And then on the left, 2x minus 1x is 1x minus 6. And this is an example where, because 2 minus 1 is just 1, I mean, you can do the dividing by one step, but it really doesn't matter. And you don't even need to write the 1 in front of the x. Now, there's not much that we need to do at this point to finish getting x by itself. The only thing that we need to do is get rid of this minus 6 by adding 6 to both sides. So then that leaves us with x equals 10 as our final answer. So that was an example where you didn't need to do both the adding and dividing. All you needed to do was add 6 to both sides, and then x was by itself. Now, since we're in the section where there's going to be multi-steps to solve these types of equations, there are going to be some equations that contain parentheses. So specifically, inside the parentheses will be one of the variables that you're trying to get by itself. So if you remember back from the several videos ago, the way to clear out parentheses is by distributing. So if you see an equation that contains parentheses, you need to get rid of those parentheses first before you do anything else. And that will even include combining like variable terms, because the parentheses are really going to get in the way because one of your variables is going to be trapped inside it. So if you see parentheses, take care of them first. Figure out what is being multiplied by those parentheses and distribute it. So you're going to distribute first before doing anything else. Then, once the parentheses are cleared out, then if you have more than one term with a variable, you're going to then combine them. If they're on the same side of the equal sign, then you just combine them like normal by adding their coefficients, and that's it. If the variable terms are on opposite sides of the equal sign, you will need to do the opposite operation in order to move them all onto one side. Then, once you have only one term that contains a variable, then you're going to begin getting that variable by itself. So you're going to undo any adding or subtracting. Then, as a last step, you will finish getting the variable by itself by undoing any multiplication or division. And then remember, if your coefficient is a fraction, you will multiply both sides by the reciprocal. Now, please make a note that not all of these steps are going to be necessary for every single problem, as we saw in this last one where we didn't need to do any dividing. So there are going to be plenty of equations where some of these steps may not be necessary. These steps are just a general guide and a kind of a worst case scenario. So worst case scenario, you'll have to do all of this, but there will be some problems where maybe you don't need to do any adding or subtracting, or maybe you don't need to do any multiplying or dividing. So just keep in mind that not every single step is going to be necessary for every single individual problem. So this is an example of an equation that contains parentheses. So the first thing that I'm going to do is I am going to get rid of those parentheses by figuring out what is being multiplied by the parentheses. The parentheses are being multiplied by a -3. So the first thing that I'm going to do before doing anything else is I am going to distribute -3 to everything in the parentheses. And anything that is not involved with those parentheses or the distributing, I am going to leave alone. So this 2t over here on the left, I'm just going to leave it alone. Leave the equal sign where it is, and I am going to distribute -3. So -3 times 1t is -3t. And then don't forget to distribute it to every single term. So -3 times -5 is +15. Now I am going to begin now I'm going to begin solving. So the next thing that you notice is, first with the distribution, the parentheses are gone now. Now you might notice that there is more than one term with a variable. There is a +2t over here on the left and a -3t over here on the right. So the first thing that I'm going to do is I am going to move all of the terms that contain a variable onto one side, and I'm going to do that by getting rid of this 3t. So I'm going to add 3t to both sides to move all of the variables over here to the left. So what's left over on the right after those cancel out is 15. And then 2 plus 3 is 5t. Now that you have one single term that contains a variable, now you're going to work on undoing any of the operations that are being done to that variable. And you might notice that the only thing being done to the variable is that we are multiplying by 5. So there's nothing to add or subtract here. We don't need to do this adding or subtracting step. All we have to do to finish getting t by itself is divide both sides by 5. And we get t equals 3 for our final answer. So each of these is going to be the same general idea. Now the thing with distribution is that distribution only applies to the parentheses. So as soon as the parentheses stop, distribution also stops. So you're not going to distribute to any term that is not inside the parentheses. So taking a look at this next one here on the left, I see parentheses, so I'm going to take care of that first. So I'm going to figure out what the parentheses are being multiplied by. The parentheses are being multiplied by 6. So I am going to distribute 6 to everything in the parentheses to clear out the parentheses. Now here's the thing. You see this -2 over here? That is not in parentheses. So we are not going to distribute the 6 past the parentheses. So this -2, I'm just going to leave alone. It is not going to be part of the distributing. As soon as parentheses stop, distributing stops. And anything that is not involved with the distribution or the parentheses needs to be left alone for right now and left exactly where it is. So here we go. Let's distribute the 6. So 6 times 1x is 6x. And then 6 times -7 is -42. Again, I'm going to leave that minus 2 where it is, going to leave the equal sign where it is, and then I'm going to leave the 5. And another thing I should point out is if you have any like terms in general on the same side of the equal sign, you should always combine them, even if they don't have variables on them. Like, first of all, I'm looking at this negative 42 minus 2. Both of these terms do not contain a variable, so because of that, they're considered like terms. So I'm just going to combine those two terms right away to a minus 44, just to get that out of the way. Now, you might also notice that there is only one term with a variable on it, so I don't have to worry about moving all the variables onto one side. There's just this 6x here. So I am now going to start getting x by itself. I'm going to start by getting rid of this 44 by adding 44 to both sides. So those will cancel out, leaving you with 6x here on the right equals 49. Then we're going to finish getting x by itself by dividing both sides by 6. And then remember, you can leave your answer as a fraction as long as it is fully reduced. 49 and 6 do not have any common factors, so you can go ahead and leave it as a fraction. Now, this next one is definitely going to be more complicated because, as you notice at first glance, there is an x on the left and there is an x on the right. So this is going to involve more steps to solve it. Now, as soon as you see parentheses, you really need to take care of them first and clear out the parentheses. You clear out the parentheses using distribution. So what are the parentheses being multiplied by? They are being multiplied by 5, and since 5 takes the sign to its left, they are being multiplied by a positive 5. So what I'm going to do is I am going to distribute positive 5 to everything in the parentheses, and as soon as the parentheses stop, distributing stops. And anything that is not involved with the parentheses or the distribution needs to be left alone for right now and left exactly where it is. So I'm going to leave this 2x minus 6 alone. Leave the equal sign where it is. This 8, leave it alone. And I'm going to clear out the parentheses by distributing 5. So 5 times 1x is positive 5x. And then 5 times 9 is positive 45. Then I am going to move all of the variable terms onto one side of the equal sign. So you can do one of two things. You can either subtract 2x from both sides to move them all to the right, or you could subtract 5x from both sides to move them all to the left, and it really doesn't matter. I'm going to subtract 5x from both sides of the equal sign so that all of the x terms are now on the left. So on the right, 5x minus 5x is 0. Now on this side, we have this 8 and this 45, which are both considered like terms because they're both terms with no variables. So let's just add them together and get that over with. 8 plus 45 is 53. And then on the left, 2x minus 5x is negative 3x, and then I'm leaving that negative 6 alone. Now that there is only one term with a variable, now I'm going to start getting the variable by itself. So the first thing I'm going to do is I am going to add 6 to both sides. Negative 6 plus 6 is 0 and cancels out. And then that leaves us with a negative 3x over here on the left. And then on the right, we have 59. Then I'm going to divide both sides by negative 3. Now 59 and 3 do not have any common factors, so this is fully reduced, and a positive divided by a negative is a negative. So I'm just going to leave this as negative 59 over 3, and then that is going to be our final answer. So these next two are going to be very similar. Keep in mind, if you have more than one variable term, pay attention to whether the variable terms are on the same side of the equal sign or opposite sides of the equal sign. If they're on different sides of the equal sign, you'll need to do the opposite operations to move them all onto one side or the other. But if they are on the same side of the equal sign, you just combine like terms like normal, and you don't have to worry about opposite operations. Also, since both of these contain parentheses, you need to distribute to clear out the parentheses first before doing anything. So I want you guys to try these next two. Go ahead and pause the video and resume when you're ready to check your answer. All right, so for this next one, the first thing that I'm going to do is I am going to distribute to clear out the parentheses, and you distribute whatever the parentheses are being multiplied by. The parentheses are being multiplied by this 7, so I'm going to distribute the 7 to the parentheses. Now, as soon as the parentheses stop, distributing stops. So this plus 7x, which is not in the parentheses, you're just going to leave alone, and the same thing with the equals 9. So let's distribute 7. 7 times 1x is 7x. And then 7 times 6 is plus 42. Now you'll notice that you have more than one term with a variable on it, but the two variable terms are on the same side of the equal sign. This 7x and this plus 7x here, they're both on the left side of the equal sign. So you can go ahead and just combine them. 7 plus 7 is 14. X. You don't have to worry about any opposite operations when the two variable terms are on the same side of the equal sign. Now that we have just one term with a variable on it, now I'm going to start getting that variable by itself. So I'm going to subtract 42 from both sides first. That will give us 14x is equal to negative 33. Then I'm going to divide both sides by 14. And then you just check to make sure it's reduced. 33 and 14 do not have any common factors, so negative 33 over 14 would be your final answer, because remember, a negative divided by a positive is a negative. So then for this next one, it's going to be the same idea. As soon as you see parentheses, you need to take care of those first before you do anything else. And as soon as parentheses stop, distributing stops. So the parentheses are being multiplied by this positive 8. So I am going to distribute the 8 to the parentheses, and anything that is not the parentheses is going to be left alone and left exactly where it is. So 8 times 1x is going to give you 8x. And then 8 times 4 is going to be positive 32. And then I'm just going to leave that minus 4 alone, equals, and I'm going to leave everything on the right side of the equal sign alone. Then you'll notice that there is more than one term with a variable. We have an 8x over here on the left and a positive 4x over here on the right. So since they're both positive, some subtraction is inevitable, and we need to move all of the variable terms to the same side of the equal sign before we can really start getting the variable by itself. So you could either move all of the variable terms to the right side of the equal sign by subtracting 8x from both sides, or you could move all of the variable terms to the left side of the equal sign by subtracting 4x from both sides. Either way, it doesn't really matter. I'm going to subtract 4x from both sides to move them all to the left side of the equal sign. So then on the right, 4x minus 4x cancels out, leaving you with negative 1. Don't forget that 1 took the sign to its left, so it's technically negative. And then over here on the left, we've got a lot to do. Let's start with the variables. 8x minus 4x is now 4x. And this 32 minus 4, they're like terms technically because they don't have variables. They're constants. So let's just combine like terms while we're at it. 32 minus 4 is positive 28. So now we're going to start getting x by itself. So let's start by subtracting 28 from both sides. And then on the left, 28 minus 28 is 0 and cancels out, leaving you with 4x, equals negative 1 minus 28 is negative 29. Then we're going to finish getting x by itself by dividing both sides by 4. And 29, 4, they don't have any common factors, but a positive divided by a negative is a negative. So x equals negative 29 over 4 will be your final answer. So keep in mind that in general, when you're solving an equation, those steps that I gave you a few slides ago, think of them as a general guideline. But if you don't, let's say, have parentheses, you don't have to distribute anything. So some steps might be required, but some steps may not be, and it really depends on how complicated the problem is and what you have in the problem. Also keep in mind that if you have, let's say 3 terms with a variable on it, you might need to combine variable terms more than once. So some steps may need to be repeated depending on how complex the problem is. So I'm going to do this next one with you. I have 4x minus 5 equals 8x minus 7. There's no parentheses. So because there's no parentheses, you don't need to distribute. But what you do have to do is combine all of the variable terms so that there's only one term with the variable on one side of the equal sign. And since the variable terms are on opposite sides of the equal sign, you're going to need to do opposite operations to move them all onto one side or the other. So since this 4x is positive, you could move it to the right side of the equal sign by subtracting 4x. Or you could move the 8x to the other side of the equal sign by subtracting it. And it really doesn't matter which side you pick, but you're going to pick a side and stick with it. So I'm going to subtract 4x from both sides. So 4x minus 4x is 0, leaving you with minus 5 over here on the left. And on the right, 8x minus 4x is going to be positive 4x, and then you're going to leave that minus 7 alone. Then you're going to, now that there's only one term with a variable, now you're going to start getting that variable by itself by adding 7 to both sides first. So negative 5 plus 7 is positive 2 equals 4x. Then we're going to finish getting x by itself by dividing both sides by 4. And then yes, you will get a fraction, but just make sure it's reduced. 2 over 4 can reduce to 1/2. So x equals 1/2 would then be your final answer. Now this next one is a lot more complicated. So for this next one, the first thing that I notice is that there are parentheses. So I'm going to take care of the parentheses first. Now, another thing I want to point out is that when I'm teaching, I do tend to go in baby steps so that people can see exactly what I'm doing in each step. So you might see how there are some steps that you could probably do at the same time. So you might be able to, say, combine like terms over there on the left and distribute all at the same time. There's nothing wrong with that. I'm going to do them in separate steps. This way I make sure that I don't lose anybody and that I don't have an instance of somebody not following what I just did. So I'm going to go in little baby steps for this. Just keep in mind, a couple of these you could probably do at the same time. But first thing I'm going to do is I'm going to clear out these parentheses by distributing. The parentheses are being multiplied by 2. So I'm going to distribute 2 to everything in the parentheses. And for right now, I'm just going to leave the entire left side of the equal sign alone. I'll deal with it later. So let's clear out the parentheses. So 2 times 1 is 2. 2 times negative 2x is negative 4x. Now, there are lots of terms that contain variables. There's 2 terms with the same variable here on the left, and there's another term with that same variable on the right. So let's just do this one at a time. On the left, I've got this positive 3x and this negative 5x. Since these 2 terms are on the same side of the equal sign, I'm just going to combine them like normal by just adding them together exactly like I see them. So 3x plus negative 5x is negative 2x. So I just went ahead and combined those two, leave the plus 4 alone, and then leave everything else alone. So I've gone ahead and took those 2x terms that were on the left and just combined them like normal. However, we're not totally done with that step yet because there is now a negative 2x over here on the left and then a minus 4x here on the right. So, because we have variables on opposite sides of the equal sign, we need to move all of the variables onto one side of the equal sign by doing opposite operations. So you could either add 2x to both sides to move them all to the right, or you could add 4x to both sides to move them all to the left. I'm going to add 4x to both sides so that I move all of the x terms to the right side of the equal sign. So on the right, negative 4 plus 4 is 0, leaving us with 2. Leave the equal sign where it is. And then on the right, let's finish combining our variable terms. So we have negative 2x plus 4x is 2x, and then we have plus 4. Now that we have just one term with a variable, now we can start getting that variable by itself. So the first thing I'm going to do is I am going to subtract 4 from both sides. That gives us 2x left over here on the left equals 2 minus 4 is going to give us negative 2. Then I'm going to finish getting x by itself by dividing both sides by 2. So that gives us x equals negative 2 divided by positive 2 is negative 1. So x equals negative 1 is now our final answer. So these are just general steps to solving any sort of type of linear equation. The number of steps that are necessary really depends on what's in the problem and how complicated the problem is. You also notice, like you saw in that last one, where some steps may need to be repeated. Like we combine like variable terms twice because we just had so many terms with the same variable on it. So just keep that in mind. So not all of these steps are going to be necessary for every single problem, but this is going to act as a general guideline of what you should do and in what order. So if you see parentheses, you should focus on them first. And if you have like terms inside the parentheses, you're going to make your life a lot easier if you just combine them right away. So combine like terms in the parentheses if there are any. Then, once all of the terms in parentheses that you can combine have been combined, then you're going to clear out the parentheses by distributing. Once the parentheses are cleared, if you have more than one term with a variable, you are going to then combine all like variable terms. And remember, if the two variable terms are on the same side of the equal sign, you just add them like normal. If they're on opposite sides of the equal sign, you're going to do opposite operations to move them all to one side or the other. Then you're going to undo any adding or subtracting. And then as your last step, you're going to undo any multiplying or dividing. So together, we're going to solve this equation. This is a much more complicated equation, so it's going to involve quite a few steps to solve it. Keep in mind, throughout this entire process, your equal sign should never move. All right, first thing I notice is I have a couple different sets of parentheses. Let's first look at the terms that are inside the parentheses. So inside this first parentheses, I have x and 5, not like terms. So there's no like terms to combine in the parentheses. And then in the second set of parentheses, I have x minus 2, which again, they're not like terms. So this first step, combine like terms in the parentheses, since there aren't any, we don't need to do that step. Next thing we're going to do, though, is we're going to distribute to clear out the parentheses. And I cannot stress enough that as soon as the parentheses stop, distributing stops. So what is being multiplied by this first set of parentheses? This first set of parentheses is being multiplied by 2. So I am going to distribute this 2 to just the first set of parentheses. And as soon as these parentheses stop, I am going to stop distributing 2. So 2 times 1x will give us 2x, and then 2 times 5 will give us positive 10. Then, since the parentheses stopped, I am not going to distribute the 2 anymore. And I'm going to do basically the same thing for the next one. So this next set of parentheses, what are they being multiplied by? And remember, if you see a negative just kind of hanging out in front of parentheses like this, there is technically a negative 1 that is being multiplied by your parentheses. So I'm going to clear out this second set of parentheses by distributing negative 1. And as soon as these parentheses stop, distributing negative 1 also stops. So negative 1 times 1x is negative 1x, and then negative 1 times negative 2 is positive 2. Then I'm going to leave the equal sign where it is, and I'm going to leave the entire right side of the equal sign alone, and I will get to that later. Next, after you've cleared out all the parentheses, then you're going to combine like variable terms. And you notice there's a lot of them. There's a 2x and a negative 1x, both here on the left. and there's a positive 4x here on the right. So we're going to kind of do this in stages. First thing that I'm going to do is I'm going to take these two variable terms that are on the same side of the equal sign, and I am going to combine them. And since they're on the same side of the equal sign, I don't need to worry about order of operations here. Sorry, I don't need to worry about opposite operations here, excuse me. So 2x minus 1x is just going to combine to positive 1x. And while I'm at it, I have this positive 10 and this positive 2, which are also considered like terms. Let's just combine those as well, get that over with. So 10 plus 2 gives us positive 12. Leave the equal sign where it is, and we have 4x plus 6. However, we are not ready to start getting the variable by itself yet because we still have more than one term of the variable. So this was an example where we had to repeat step 3 twice. So we have now a 1x over here on the left side of the equal sign and a 4x over here on the right side of the equal sign. Since they are on opposite sides of the equal sign, we're going to need to do some opposite operations to move them all onto one side or the other. So we can either subtract 1x to move them all to the right side, or we could subtract 4x to move them all to the right. And it really doesn't matter. I am going to subtract 1x from both sides of the equal sign to move them all to the right side of the equal sign. So 1x minus 1x is 0 and cancels out, leaving you with a 12. Leave the equal sign where it is, and then 4x minus 1x is then 3x. And then just leave the plus 6. And now that you have just one term with a variable, now you can start getting that variable by itself. So the next thing we're going to do is we're going to undo any adding or subtracting. So I'm going to subtract 6 from both sides, giving us 12 minus 6 is 6 equals 3x. Then I'm going to finish getting x by itself by undoing any multiplication or division. So then I'm going to divide both sides by 3, leaving us with x equals 2. So x equals 2 is going to be your final answer. This next problem is probably this is probably the most complicated type of problem I would ever ask you to solve. So also keep in mind that within any sort of grouping symbols, such as parentheses or brackets, you do still need to kind of follow these general steps to solving. So just keep that in mind. Because the first thing that you run across when you read this problem from left to right, you do see that there are brackets here, and inside the brackets we have parentheses. So distributing will clear out any sort of grouping symbol, but even within parentheses or brackets, you will still need to solve the general steps to solving linear equations. You will still have to do these steps. So as soon as you see grouping symbols such as parentheses or brackets, you're basically going to mentally restart these general steps and then go through, okay, do I have any parentheses? I got to clear those out, etc. So if you look inside the brackets we have a set of parentheses. Now inside the parentheses we just have x minus 1, which are not like terms, but since we're restarting these general steps, we do need to clear out those parentheses by distributing. So that's the first thing that I'm going to do. What are the parentheses being multiplied by? They are being multiplied by positive 2. So I'm going to distribute the 2 just to the parentheses. And as soon as the parentheses stop, distributing stops. Now on this side of the equal sign, anything that is not involved with those parentheses or that distributing needs to be left alone and left exactly where it is. So this 13 and that minus that are both outside the brackets, leave them alone. This 4 was not involved with the distributing, so you're going to leave it alone. And then I'm just going to distribute the 2 to everything in the parentheses. So 2 times x is positive 2x, and then 2 times negative 1 is negative 2. Now on the right here, I do have another set of parentheses, so I am going to distribute to clear out these parentheses as well. And since they're on opposite sides of the equal sign, you can go ahead and do these two at the same time. So since the parentheses are being multiplied by 3, I am going to distribute the 3 to everything in this set of parentheses. So 3 times x is 3x, and then 3 times 2 is positive 6. Now, keep in mind, we still have grouping symbols. We still have these brackets, and these brackets, they do the same thing as parentheses. So you're going to, since we still see grouping symbols, again, mentally restart these general steps. First thing you do, you combine any like terms that are in the brackets, if there are any. So take a look inside the brackets. Do we have any like terms that are inside the brackets? We do. This 4 right here and this minus 2. These are considered like terms, so let's save ourselves some headache later, and let's combine the like terms that are inside the brackets next. So I have this 13 minus 4 minus 2 is going to give us 2. And then equals 3x plus 6. However, we do still have grouping symbols, and remember, the only way to clear out parentheses or brackets is to distribute. So what are the brackets being multiplied by? They are not being multiplied by 13. The brackets, since there's a negative just in front like this, the brackets are technically being multiplied by negative 1. So I am going to multiply negative 1. So I'm going to distribute negative 1 to the brackets to clear out the brackets. And this 13 that's in front of it, just going to leave it alone. And I'm going to leave the entire right side of the equal sign alone. And I'm just going to work on getting rid of these brackets finally. So negative 1 times 2 is negative 2. And then negative 1 times 2x is going to give us negative 2x. And now all of the grouping symbols are finally gone. So now that the grouping symbols are gone, you need to take a look at, is there more than one term with a variable on it? And yes, we have a negative 2x over here on the left and a positive 3x over here on the right. We need to move all of the variable terms onto one side of the equal sign before we start getting any variables by themselves. So we can do one of two things. We can either move all of the variable terms to the right side of the equal sign by adding 2x to both sides. Or we can move all of the variable terms to the left side of the equal sign by subtracting 3x from both sides. It really doesn't matter. Pick a side and stick with it. I'm going to add 2x to both sides of the equal sign to move them all over here on the right. So then on the left, negative 2x plus 2x is 0. And while we're at it, 13 minus 2, these are technically like terms. Let's just combine them. 13 minus 2 is 11. Equals, and then on the right, 3x plus 2x is going to give us 5x, and then plus 6. So now that we only have one term with a variable, now we're going to start getting that variable by itself. So I'm going to subtract 6 from both sides. Gives us 5x is equal to 11 minus 6 is 5. Then I'm going to finish getting x by itself by dividing both sides by 5. I am out of room, but we're done. So x is now by itself equals 5 divided by 5 is 1. So x equals 1 is then your final answer. So keep in mind that this is like the most complicated type of problem that I would ever ask you to solve. So if you have parentheses inside of brackets, you need to take care of those inner parentheses first, clear them out by distributing, combine any like terms in the brackets, and then clear out the brackets by distributing. So that is going to be it for section 8.3, which is solving linear equations involving either 2 steps or more than 2 steps. So just keep in mind that the number of steps that are necessary all depends on what's in the problem and how complicated the problem is. So in the next video, we're going to be looking at a few basic applications of solving linear equations. So look forward to that video when it is posted. So thank you all very much for watching, and I will see you all in the next video. Bye-bye.